In this lesson, we will discuss the occurrence and extraction of sodium and aluminium. Rocks from which metals can be extracted are called ores. An ore is any naturally occurring source of a metal that you can economically extract the metal from. Extraction of metals from their ores involves the following general process. Getting the ore from the ground. If the ore is near the surface, use open cast mining or quarrying. If it is deeper into the earth's crust, use deep mining. Concentration of the ore. Froth flotation. This method is used when the percentage of mineral in the ore is too small. In this process, the ground ore is mixed with water and oil and air blown into the mixture. Chemical leaching. The crushed ore is first dissolved in a chemical where only the ore can dissolve. It's filtered and the purified ore is crystallized and then crystallized out of the filtrate. Reduction of the ore to metal. There are two major methods of obtaining the metals from the use: reduction by carbon and electrolysis. The following is a summary of the way metals can be obtained from their concentrated ores depending on their position in the electrochemical series. Sodium metal is extracted by the Downs process where molten sodium chloride is electrolyzed. Calcium chloride is added to sodium chloride to lower the melting point of sodium chloride from 800 degrees Celsius to 600 degrees Celsius.
There's a problem though. Chlorine is a powerful oxidant and sodium metal is a powerful reductant. So if you could find a way to convert them from the sodium and chlorine ions in salt water, you'd have to somehow keep them well apart. A way to do this was figured out by an American chemical engineer called Jakes Cloyd Downs in the 1920s. The cell he devised produces sodium and chlorine, but keeps them apart with a simple but effective iron mesh screen. The Downs cell has a central carbon anode and a cylindrical iron cathode. Neither electrode takes part in the reaction. Solid sodium chloride is a poor conductor, so it's heated to melt it. The electrolyte is actually a mixture of molten sodium chloride and calcium chloride. The calcium chloride plays no part in the reaction. It's there because it lowers the temperature needed to keep the electrolyte molten. At the anode surface, the power supply pulls electrons from chloride ions, which form molecules of chlorine. Here's the half equation. At the cathode, electrons from the power supply are forced onto the most reactive cations, the sodium ions. Here's the half equation for the reduction of sodium ions to liquid sodium metal. The iron mesh screen allows sodium and chloride ions to pass through it, but keeps the products apart. Since the liquid sodium is less dense than the electrolyte, the sodium floats up into a hooded structure as the reaction proceeds and is tapped off. Meanwhile, chlorine gas bubbles up from the anode into a separate vent. Here's the equation for the overall reaction.
The animation below shows how sodium metal is extracted using the Downs process. During electrolysis, sodium metal forms at the cathode, whereas chlorine gas forms at the anode. A steel diagram is suspended between the electrodes to prevent sodium and chlorine from recontinuing. Molten sodium is less dense than molten sodium chloride, hence it rises than molten sodium chloride. Hence, it rises to the top of the cathode from where it is removed periodically. The liquid sodium is collected and also solidifies and can be stored for use. To make an alloy with lead, which is used to manufacture tetraethyl lead, an anti-knock additive in petrol. For the manufacture of sodium compounds such as sodium cyanide used to extract gold and sodium peroxide. An alloy of sodium with potassium is used as a coolant in nuclear reaction. Sodium vapor is used in sodium lamps, which gives yellow-orange light.